Okay, let's get started. So a very good morning to all of you. How are you all doing today? Are you able to hear me?
Yes, sir.
Yes, sir.
Okay, very good. So how is it going for all of you? So we know that there's COVID has literally created a havoc in the market or even in the day-to-day life of people. But hopefully all of you are safe and all your family members are safe. Okay, please do take care of yourselves. Okay, so very good. So can we quickly have an introduction of who all are there in the session, so that I can know what is the background from where you guys come from, so that I can tweak my webinar in such a way that all of you will be able to get what I'm trying to talk about. Anybody who would like to introduce themselves?
I am Mandeep Suri and I am doing a data science course since January from INSEAD.
Very good, Mandeep. Thank you for your introduction. Who else would like to talk? Yeah, anybody who would like to introduce themselves? Subhash? Yeah, go ahead and introduce yourself, please. Okay, not able to hear you. Okay, how about others? Jitendra? Rishabh? Okay, it's Wednesday morning, guys, not Monday morning. All right, so that's fine. So let's go ahead and see what we have in this webinar today so that we get prepared to understanding some interesting topics. Okay, let me share my screen. Okay, are you all able to see my screen? Introduction to Cloud Data Engineering?
Yes, yes.
Okay, very good. All right, so how many of you know about cloud already? So what do you know about cloud? When we talk about cloud in the modern day data engineering, cloud computing context, what do you mean by that? Anybody?
Servers at a remote location.
Very good, Mandeep. Yeah, perfect.
Which we can hire.
Yes. So why do you think people go with cloud? Yeah, so there are specific reasons why people go with cloud. Okay, anyway, we'll discuss about that in today's discussion. Okay, see, when we are looking at cloud infrastructure or cloud as a platform, so we are talking about an on-demand availability of resources in a remote place. Okay, so when we talk about data storage or computing power, right? So we are and when we want to increase or decrease the capabilities of such a server, then we would obviously look at an option like a cloud, right? So again, cloud has different categorizations among themselves. The major ones, what is really popular today is a public cloud, and we have private clouds, and also we have some hybrid cloud concepts that some of the organizations are using. Okay, so now if you look at the future of I would say the IT industry, it is heavily banking on the cloud, right? So a lot of companies are moving towards the cloud. If you look at the major amount of projects that are going on in the data related field, so it's all about migration to the public cloud, right? So they all had data, and now they've segregated the data into what is essential and highly secure data, which they want to keep it in their own network or they want their own servers, and the rest of it they want to move it to public cloud because it is more efficient and cost efficient, I would mean. So to maintain the data on public cloud, because public cloud is something where things can be managed easily, and also it is scalable. You can scale up or scale down as and when required, right? So there are a lot of advantages of using public cloud or cloud infrastructure as such. We'll talk about that later in today's conversation. Okay, so by and large, when we are looking at cloud, we are looking at the remote infrastructure, which can be utilized for hosting our applications or any kind of IT any kind of I would say rather application or your own company's infrastructure that is handled on the cloud, right? So now let's look at what is the size of cloud computing, right, in terms of dollars, right? So it is estimated that it is around between 400 to 500 billion US dollars that's supposed to be in 2021, right? So that is the estimated size of cloud computing market. So 90% of the companies are already on the cloud, right? 89% of the companies use software as a service. Okay, so in one way or the other, you will be using software as a service. So, for example, can you name an example, give an example of a software as a service product that you're using on a daily basis? Yeah, anybody? Any SaaS product that you're using?
GitHub.
Yeah, GitHub. Yeah, that's a good one. So yeah, you have a lot of things, right? So you even when you're using Microsoft Outlook, you're using software as a service, right? So basically, you're paying, if at all you're paying, you're using the paid version of that, right? So a lot of applications are there wherein you're giving a monthly payment to them and using it as an application, right, as a service. So now in India alone, it is supposed to be a booming market in 2021. They say the cloud computing is supposed to be a booming market in India with around some roughly around 5 billion US dollars in 2021, 4 to 5 billion US dollars, which itself is a huge advantage for say when we talk about India and cloud computing market. So we're talking about the consumption here. So apart from that, when we look at the job opportunities, a lot of people are getting employed for projects which are being deployed in United States or Canada, Australia, or any other advanced countries. And that is where our services play a major role, wherein we may not be the direct consumers of the cloud as such, but we are indirectly in the game, wherein we are providing the required services for working on the cloud infrastructure. Okay, so let's see what is the growth rate, right? So now if you see AWS, Azure, Microsoft Azure and Google Cloud are the major players in the cloud. I would say Google Cloud is still evolving. So rather it is AWS and Microsoft Azure. So now if you see 2018 onwards, Microsoft Azure has been having a phenomenal growth, right? So, and quite so because Azure is something where Azure is a platform which has been customized. I can hear some background noise. Can you please, all of you, switch off your or mute yourself, please? Yeah, thank you. So now if you see Microsoft Azure, so just as a comparison between Q3 of 2020 and Q4 of 2020, we see a percentage growth, which is 50% growth quarter to quarter. Okay, so of course we do have a good statistics about AWS as well. But at some point, AWS is also reaching a saturation. In the sense, it is not kind of growing at the rate what Azure is growing, right? So Azure, in a couple of years back when we were doing the training sessions, we were talking about Azure's growth rate or Azure's market share as somewhere around 15%, 16%. Now we are talking about 20% market share. And also, right? So Azure, Microsoft Azure has been evolving in such a way that it caters to the data engineering or cloud computing and cloud computing, data engineering, or I would say data analytics and related services, right? So if we take the basic data engineering, or we talk about the big data, we talk about Internet of Things, artificial intelligence, machine learning. There are services which can help you work on these areas, right? So there are services which are specifically built to enable you to work on these areas. So that being said, Azure has been evolving very efficiently, catering to the market needs, because the whole market is very responsive to the needs of data and related services, right? So that's how it's been evolving. So something which is very interesting for us to consider Azure as a subject area to study and understand, considering the future prospects. Okay. So let's look at the cloud market share and growth again. So if you see here, you can see that Q2 of 2020 already Azure was 20%, was having 20% market share. Q3 of 2020, 19%. Again, Q4 has been 20% again. So if you see, there is growth. See, if you see Q3 of 2019, it was 17%. There's almost a 3 to 4% growth until now when you look at Azure. Obviously, so it is eating into somebody else's market share, right? So obviously the AWS market share is either stagnated or it is coming down on certain quarters, right? But I would not say that AWS is coming down in any way. Definitely AWS has its own advantage, has its own set of customers who are utilizing the AWS platform to the best extent. But I would rather say that the next few years will be Azure's time, wherein people will heavily leverage Azure's capability for data and related subjects. Okay, but first let's see what is cloud computing. So when we talk about cloud computing, so obviously we discussed already what is cloud computing. So we are talking about a practice of using a network of remote servers, okay, hosted on the internet to store, manage, and process data rather than a local server or a personal computer. Okay, so when we say remote, what is it that we're talking about? Where is it located? Anybody? When we talk about remote servers, where are we talking about? Where is it located? Yeah, I would like if the class is interacting enough. What do we mean when we say remote? Yeah, anybody?
Without being in physical contact.
Without being in physical contact, yeah.
With the server.
Server, yeah. I'm specifically trying to know what do you mean by remote servers. Remote. Where is it located? When you say remote,
Different
physically.
parts of the world, in Mumbai. In
very good. Yes.
Different cities.
Oh, who is this? It says Redmi.
Sufyan.
Sufyan. Okay. Yeah, good, Sufyan. So that's exactly what it is. We don't know where it is. It is somewhere over there in some part of the world, right? In some geographic location, it is located. Now, when we talk about cloud, especially public cloud, we specifically don't know where it is, but we can specify when we are setting up the cloud infrastructure for our organization. We can specify saying that, oh, I want it to be in US geography. I want it to be in Asia Pacific. So we can specify where we want the servers to be located, but they will not let us know where exactly it is physically located, because letting everybody know where it is located is also a way with which they are letting the information out, which can be a threat to the security for the data, right? So we don't know. It is located in remote. Yes, it is located in remote. Where it is, we don't know. But geography wise, we can specify. But we don't know whether it is in some part of Delhi, some part of Mumbai, or some part of Bangalore. Where exactly, which building? No, nobody knows that, right? So we're talking about remotely hosted data. So now, when we talk about cloud computing, it's a practice, right? Computing is a practice. Cloud is something where there is a presence of infrastructure or a platform. So now cloud computing is a practice wherein you use a network of remote servers, right? So it can be one server or a network of remote servers hosted on the internet to store, manage, and process the data rather than a local server or a personal computer. Now, can you give me an example of storing the data? When do you store the data? So what do you mean by storing the data? Anybody?
Sir, it's like Google Cloud, right?
Google Cloud. Okay, what application are you talking about here?
So data in form of photos and videos we can, I mean,
Excellent, very good, Rishabh. Yeah, perfect. That's a very good example. So now if you're using the Google Cloud to store the documents such as the files that you're working on your project, or your images or anything, or your videos or anything like that, if you're storing it on the cloud, so it is actually storing the data, right? It, instead of your local machine, you're storing it on the remote computer. Google will not tell you this is exactly where it is storing the data, right? So it just says it is on the cloud. And for all we know, it will be in the Google Cloud, okay, Google GCP. So yeah, that's a very good example. Anybody else? Any examples of high security applications?
Google Drive.
Yeah, Google Drive. Yeah, Google Cloud. Google Drive is on Google Cloud. That is,
Okay.
yeah, that is exactly what it is. Yeah. Anybody else on? Let's talk about some application which requires high security. I'm not talking about public cloud or private cloud here. I'm just talking about generically about cloud. So wherein you don't know where the data is getting stored, but for sure you know that it is not stored in the local machine. Okay, it is going to somewhere else which is in the remote. Any other example? I want a highly secure application as an example. Anybody?
so Microsoft OneDrive.
Yeah, OneDrive is also very similar to Google Drive. Yeah. So Microsoft OneDrive, again, you can install that application in your local, even for Google, you can do that. So wherein you can start pushing the data on a regular basis to the remote. Fine. So these are all situations wherein you may not be working on a highly secure data, right? So you're talking about the day-to-day files that you're generating. But of course, there is possibility for you to keep secure data also. But can you give me an example of any transactions that are happening, highly secure transactions which are actually going and sitting on the remote machines? Yeah. Transactional data. Think about it, transactional data.
Google Pay, Phone Pay.
Excellent. Very good. Very good. Why do you think it is a highly secure data? Yeah. What makes you think that it is highly secure?
Sir, I think it have its own digital signature.
Yeah, because see, primarily it's dealing with the banking transactions, right? So if this data is compromised, then money is at stake, right? We don't know who has what amount of money in their bank, right? In the banking transaction, if for some reasons your bank account credentials are compromised, then there's a huge loss, right? So, and again, when we talk about some of the companies which have a lot of transactions on a hourly basis, for example, if you see, there are a lot of people who are purchasing products on Amazon, right? Every hour there are millions of transactions across the world, and most of them are using their credit cards to make the payment, right? So now, when such a transaction is happening, it is very important for high security to be in place. Okay. So now, similarly, when you go to an ATM machine, you swipe your card and you withdraw money or do any kind of transaction on the ATM machine. The data is not sitting in the ATM machine. Do you think that the data is sitting in the ATM machine on how much money was withdrawn? What happens? Can anybody explain me what happens at that as part of the transaction? Yeah. Okay, so when you do a transaction on an ATM machine, essentially what you're doing is you're instructing your bank to either give you some money as a result of your approval to get that money, or you're doing any other transaction wherein the data or the transaction itself is getting saved on a remote database, right? Saying, okay, this is what was done, this is what was agreed, right? So essentially, when we are doing transactions using ATM machines, there is a high security protocol that is being followed while executing the transactions. Okay. At the same time, the data is sitting in a remote machine, right? It is not sitting in a local machine there, right? So the ATM machine itself may be a system, but that will be pushing the data to a remote server, or it will be getting the data from a remote server, and we don't know where it is, right? So again, the concept of a remote servers being in operation is very, very important to understand in that context. Okay. All right. So let us try to understand what is cloud data engineering. So what is data engineering? Anybody?
Like that, sir. I think
Hmm.
it could be related to something pipeline or
Pipelines, yeah,
structure.
pipeline, data pipeline is an important aspect when we're looking at the ETL
Data
process.
collection and data analysis.
Collection and analysis, very good. Yeah, very good. Yeah, I like those answers. Very good. So that is motivating enough for me. Yeah. So now see, when we look at data engineering, we're talking about collecting, curating, and aggregating data from multiple different kinds of sources. Okay. So why do we do this? We do this to create a consolidated data platform, right? That can be consumed by the downstream systems, right? To empower the data-driven decisions. Okay. So now if you look at the leadership team in any organization, they will be making decisions based on data, right? So if you see, for example, the sales directors in the company, so if they want to forecast what will be the sales for the next 1 year, they'll normally look back to the past, right? They'll look back to the past and try to understand what exactly happened in the past 1 year or 2 years. Okay. And based on that, they will see, or they will extrapolate, right? Okay, this is the prediction, this is the prognosis, this is the prediction for the next coming year. And I'm not just predicting just because of any kind of prediction like that. I'm just predicting based on the past data, right? So now where do we get the past data from, right? So there's a process, there is a protocol based on which we'll take the data, aggregate them, consolidate them, and you also curate the data, right? So you check for what is the garbage data, what is real data, what is usable data, and then bring them all together into a data warehouse, which can be used by the downstream systems, by the business intelligence applications for decision making process, right? So data engineering is the core of any kind of data related activities in an organization, right? Even when we talk about big data, data science, or Internet of Things, any aspect as such. So we have to do data engineering to do the analysis on the data, right? Without data engineering, you're not ready to consume the data, because data lies in the form of raw data, and it is not available as something from which information can be derived, right? There's a huge difference between the data which is lying there as raw data and information through which you can make decisions, right? So this is the journey between the data and the all the way until the information, right? So when we look at a data engineer, so something which will be the future of something which will be a very sought after job role in 2021 and 2022 is the job role of data engineer. But now the same designation or same role was existing in the past as well, but they were called in different names. They may be called as data warehouse specialist, or cloud computing specialist, or anything like that. But specifically, we are going into the role called data engineer, because this is exactly what they will be doing. So they'll be dealing with collecting, curating, and aggregating the data from multiple sources, right? So to eventually develop a consolidated data platform or a data warehouse that can enable the decision support system of an organization to look at the data and analyze the data for decision making purposes, to run their businesses, right? So to run their businesses in in an efficient way. All right. So now, for example, if you go to the finance division of an organization, just like how I talked about sales, if you go to the finance department will say, hey, I want to see what are the receivables, but I want to see that in this context. I want to see that from the context of the customers and from the product line and in a particular date range, right? So now we are talking about multiple dimensions from where we want to see the data, right? So how much of money I'm supposed to receive, right? But I just don't want to know just from the customer standpoint. I want to know it from multi-dimensional standpoint. And again, I want to aggregate the data. I want to look at it initially at a year level, and then at a month level, and then at a quarter level, and then at a month level, right? So there is a drill through a lot of different features that you can look at for efficient analysis of the data. Now, if you see the analytics part of it or data engineering part of it is very technical in nature. When we look at data analysis, it's more functional, right? So you're basically analyzing the data and arriving at decisions or coming up with recommendations. So there's a strong differentiation here, right? So the consolidated data in data lake or data warehouse satisfies hundreds of consumer use cases, right? When we talk about use cases, it is the requirement of the businesses, right? It feeds the BI reports and empowers the data scientists, trains the machine algorithms, and so on, right? So that's what. So when we see, this is the basis, this is the central, the crux of the system here, right? Whether we are talking about analyzing the data in a IoT system or in a machine learning system or big data context. So now data engineering is a must here, right? So whether we are dealing with smaller volumes of data or a bigger volume of data is what makes a difference. That's it, right? So when we look at the ultimate aim of a data engineer, it's all about providing reliable data infrastructure, right? So we are not just talking about the data by itself, it's also about the infrastructure, right? What are those processes which are extracting the data from one system and loading it in another, right? So what are those processes which are actually testing the quality of the data, right? The complete thing becomes and then on what hardware infrastructure is it lying, right? So whether we have the sufficient processing capabilities to process the data, so the required amount of memory, so on and so forth. It's a complete infrastructure that we are dealing with, right? So now if you look at this block diagram here, so you see the data sources can be structured data or unstructured data, right? So again, that's a different topic. On anybody who knows what is structured data and unstructured data? Anybody? Yeah, give it a try, please. What is structured and unstructured data? Any example?
For unstructured photos,
Okay, photos. Yeah. Any example of structured data? Okay, let's understand that from a very basic sense. Okay, so when you're looking at structured data, so structured data is that data wherein you can easily do a search on that, right? So it's a clearly defined, okay, it's a clearly defined data. Okay, so wherein you can go ahead and search the data, right? For example, if you have data in the form of an in a database, you can go ahead and search. Okay, for example, if you have the data of all the students in the classroom stored in a database, you can go ahead and search for a specific student's name and all the details related to him, such as his age, his parents' name, so on and so forth, right? But unstructured data is usually stored in the native format, right? So so it's not very easy for you to search through the data, because it could be it could be stored in its own native form, right? So let's just understand that as it is for now. Again, it's a big topic to talk about all those things. So yeah, any other examples of structured data? Anybody? Yeah, any other example of structured data?
SQL.
SQL as a database. Okay, what are you talking about when you talk about SQL? Yeah, anybody? Okay, anyway, see, in very simple sense, let's categorize structured data and unstructured data as Structured data more as a quantitative data, right? So you know what amount of data is available, and we are looking at the data organized in such a way that the data can be retrieved and searched and analyzed in an easy way. Unstructured is it's more a qualitative data, wherein you're talking about data stored in a raw format, and it's not easy to traverse through the data and search the data. But again, we have a lot of different techniques in the modern day to traverse through and search and identify the different pieces of data, even in the unstructured database, unstructured data as well. Okay. Let's move on to the next one. So now, regardless of whether it is structured or unstructured data, so the data is brought in from different data sources. When we are looking at data engineering as a practice, so again, there is a process called data extraction and data processing that happens. So normally we call it as ETL process. And then we load the data into a data warehouse, right? So when we are loading the data, we may do it through real-time processing or batch processing. We may incorporate some algorithms related to data cleansing, right? So data validation, we may do data aggregation, and we can also schedule the jobs there, right? We store the data and we enable the data warehouse or this repository of data to be consumed by the business intelligence systems, right? So for example, if somebody is using Power BI, you must have heard what is Power BI already. You might have heard what is SAP Business Objects. There are a lot of business intelligence or OLAP tools that are available in the market, through which you will be able to analyze the data available in the data warehouse, right? So the overall process of making sure that the data is available for consumption, that actually summarizes what data engineering is all about. Okay, any questions so far? Okay, anybody, what is data? We already talked about data. What is data? Okay, so a data is nothing but facts or statistics collected together for reference or analysis, right? Okay, when we are looking at database, it's a collection of data. That's it, right? So when we are collecting data that is organized so that it can be easily accessed, managed, and updated, that's where we are talking about a database. Now, when we talk about databases, we have different kinds of databases. Anybody can you answer what, can you let me know what are the different kinds of databases that are available? Any two examples will be good enough. Yeah. You've heard of a lot of different kinds of databases in the market. Yeah, anybody? Yep. Anyone who knows about what are the different kinds of databases available in the market? Have you heard of RDBMS? Anybody? What is RDBMS? Okay, Rishabh said SQL RDBMS. Okay, yeah, RDBMS is correct. What is an RDBMS? Yeah.
Relational database.
Very good, very good. Relational database, Manju. Yeah. So why do we call it as RDBMS?
The tables are interrelated with each other, so that there will not be any duplicate values in the tables.
Very good. Excellent. Yeah, that's exactly what it is. So when we're talking about RDBMS, we are talking about a relational database wherein data is formed or data is stored in the form of tables. And again, data is arranged in these tables in such a way that there is no duplication or redundancy. And of course, we can, in simple terms, we can call it as it adheres to the protocols of Boyce-Codd's normal form, right? BCNF, right? So there are normalization principles based on which we can arrange the data in the database and that becomes a relational database altogether. Yes, very good. So now any other databases you can think about? Any other database? Yeah. Okay. So with the interest of time, we'll just move on. So we have NoSQL databases, we have graph databases, we have columnar databases or in-memory databases. Some of them are combination of multiple kinds of databases. But again, there are different ways with which the kinds of databases have been characterized and categorized, right? For example, some people want to categorize the databases based on whether it is centralized or decentralized databases, or it is these databases are centralized or decentralized or distributed databases. There are a lot of different ways with which they can categorize, but purely based on the functionality of the database by itself. You have the SQL, you have the RDBMSs, you have the NoSQL databases, you have columnar databases, document databases, graph databases. Neo4j is a good example of graph databases. Different kinds of databases are used for different applications, purely based on the advantages what it will bring to the table. Okay, so let's move on. So what is information, right? So this is exactly what we need to move towards, right? From the data to all the way to information, the facts provided or learned about something or someone. Now, if you have the sales data for the last 2 years, you have the data with you, right? So now if you know that, okay, these are the months on which the sales will be very high based on the data what you have, then that is the information, right? So you have learned something based on the data what you have analyzed, right? That's what you can categorize in information. Okay. So again, you can see the evolution of databases. Databases have evolved big time since the last 50, 60 years. Obviously, in today's world, there are different kinds of databases that are heavily used based on the kinds of applications that they are employed at. Again, categorization, no specific rule based on which it has been categorized in this particular thing. But just for convenience, if you can categorize it as centralized database, distributed databases are very widely used these days because you want the data to be available in different remote servers, and then so that they are safe, secure, and highly easily accessible. So you have cloud database, relational database, network database, object-oriented database, hierarchical databases. That is not it, right? So of course we do have other categorization as well. Yeah. Okay, well, just have a look at what is a data warehouse. Do any of you know what is a data warehouse? What is a data warehouse? Yeah. Okay, so as an empirical definition, so a data warehouse is a collection of intelligent data that is made available to the decision support system of an organization so that they can make intelligent decisions out of the data that is available in the data warehouse. Now, normally the data in the data warehouse may be in an aggregated form, so that the decision making process is much easier, right? For example, if you want to do the analysis on what was the total number of sales on a monthly basis in a particular geography, so that may not be something what you want to write a query at the runtime and get the analysis, right? It may be stored as a pre-aggregated data in the form of cubes before you retrieve the data for any further analysis. Okay, so all in all, data warehouse hosts the intelligent data, right, in a database or in a repository, such that this data can be consumed by the downstream systems for any kind of decision making process. Okay, so now again, when we are talking about data warehouse, again, similar thing to what we saw in the data engineering slide here. So we are talking about different data sources, right, from where the data is coming in. and the data is all pulled into something called as a staging area. And from the staging area, we push the data into data warehouse by applying any kind of data manipulation protocol on the data, and then the data is made available on the data warehouse, right? From the data warehouse, again, in the data warehouse, a data warehouse can be can be again divided into multiple data marts, right? So based on the subject area. For example, if you're talking about sales, if you're talking about finance, if you're talking about inventory management, each of them can be silos of information which can be considered as a data mart. And then this data is eventually consumed by the users, right? If you go to a big organization wherein you have people from the sales department, from the finance department, from the human resources department, each of them will have their own specific needs to analyze the data, right? They'll dip into that particular data mart, which has all the data, and then they'll start building the reports on that for any kind of decision making, right? So in a nutshell, very quickly, I can, because this itself will take at least 1 or 2 days of the lecture to explain what is data warehouse, just for your information, so that people who attended this this webinar will get the best out of this, right? So again, data warehouse, we have a sample data model. So we normally call it as denormalization. So as just like what we talked about normalization when we talk about relational databases, when you are talking about a data warehouse, we do the other thing. Okay, please don't write on this. Please don't. Yeah. So when we are looking at data warehouse, we denormalize the data, right? So we basically ensure that the speed at which we can query the data is very high, right? So we remove all the normalization rules which are applied on the data, and then we make sure that the data is easily retrievable, accessible, and something which can be analyzed in an efficient way. Okay. So let's go on to understand what is cloud computing what are the cloud computing services. So why do you think companies will go and get cloud computing services, or why do you think organization will go ahead and use the cloud platforms? What are the reasons, right?
Okay. Can I tell?
Yes,
So,
please go ahead. Yeah.
Okay, sir. If even if it is deleted from the computer, we can again retrieve files from anywhere in the world from using the cloud.
Yeah, correct. So what do you how do you explain that more precisely? So even if it gets deleted for whatever reasons, it is available somewhere else. What is the specific terminology for that?
Storage inside the mobile. So we can, if we have an account, even if our electronic device is destroyed or something, we can access our account and retrieve the files from.
Correct. So the data replication, right? So the data replication, and also see, suppose there is one server which actually is catering to your business application, which is down at any point in time. The same data is already replicated in some other server, right? As part of security measures, the public clouds, for example, will replicate the data in 2 to 3 different servers, right? So they have different nodes, or I would say, let's simple terms, let's call it as different geographical locations, or within the same geographical location on different servers. So they would have replicated their data. For example, if the data is going into a particular server which is located in Mumbai, for example, there may be another server within Maharashtra which will have the same data replicated, or there may be some other server in US which is getting the same data replicated almost at the runtime, right? So there is the data reliability, because the data duplication is happening, or replication that is happening, which will ensure that the data is available even in a situation of a loss, right? Sometimes there may be an earthquake because of which the server on one location may completely get destroyed, but still, because of the capabilities of cloud, it will be replicated somewhere else where the data is still intact. Very good answer, Ibn. Yeah. Any other reasons why would you look for cloud?
It can be accessed at any time.
Accessibility, yes, very good.
For multiple accessing.
can be accessed by multiple people in multiple geographies. Yes, very good.
It's a huge storage. Even if
Yeah, phenomenal. That's phenomenal. Yeah. So it's like you can scale up to any level, right? So if you, for example, if you want to have your own infrastructure to store the data in your organization, you will need racks and racks of machines to store all the data, what you can actually potentially store on a cloud, because the cloud infrastructure is immense, right? So you can store petabytes of data, right? If you really want to consume the services, because these cloud, they call it as virtually infinite amount of data, right? And that is where it is of heavy usage. Yeah, very good. Anybody else? Any other answers? Volume of data is a very important thing. Yeah. See the computing power also, right? So see now normally, just imagine a very simple scenario. You want to do a basic application. You want to run a basic application in your machine to run your retail store, right? So you have installed an application in your local system, a laptop or desktop, whatever you have, which you have kept in your retail shop. Now, if that application is processing very small amount of data, that's fine. Now, if all of a sudden you have GBs of data, a lot of transactions are happening in your retail shop. What happens when there is a lot of processing that happens? What happens in any machine when there is a lot of processing that happens? What happens to that machine?
it will slow down or it will get heated.
Yes, it will slow down. Very good. It will slow down because the resources are being consumed heavily, because of which your machine will slow down. When it slows down, it will impact your business because you are not able to operate your business in an efficient way, right? Then you will go to your computer hardware engineer and ask him, right? Oh, this is happening. What do I do? Then they will say, oh, you have to upgrade it to a higher processor, okay? Or you have to increase your RAM, right? So it can be any such requirement which may solve the issue. But again, you will have to either change your laptop or your desktop or any machine that you're using there, or you may have to shell out a lot of money to upgrade your system. So scalability is always the issue when you're having your own infrastructure, right? So now what happens on the cloud? It is just as easy as clicking things using your mouse, right? At the click of a button, you can increase or decrease the capabilities, right? The hardware capabilities. So that is, you have a concept called vertical scaling or horizontal scaling, and scaling up or scaling down. So wherein you can add in more processors, you can add in more space, or you can add in more other kind of computational capabilities. Even if you are looking at a graphical processing capability, you can increase or decrease on the cloud, right? It is very easy because it is readily available. It's just a matter of engaging that particular hardware into the processes that you're running, right? So cloud as such has immense potential, considering today's or the modern days needs in terms of developing applications or developing any kind of software interface which can help the end user by creating the right kind of value for them. Okay. Okay, just give me one moment. Yeah. Okay. So now, along with that, you also have very efficient analytics capabilities, right? I was talking to you about Azure as a platform. So when you talk about Azure, so they have very heavily focused on analytics capabilities, right? So or analytics related services or modules within Microsoft Azure, which can help the business communities take the best advantage of going ahead with using Azure. So now, Again, when we look at networking connections between cloud provider and your company, so many companies go with hybrid cloud, right? Wherein they want to use the public cloud at the same time, they don't want to compromise on using their own private cloud, right? So public and private together will be more robust and secure for some organization, wherein they can keep the highly secure data, confidential data in their private cloud or private infrastructure, and any data which is of not of that confidentiality or not of high security, they can push it to the public cloud. But again, there is, let's say, public clouds are also sought after because of security, but sometimes some organizations don't want to keep the data in public cloud like AWS or Azure or Google Cloud, only because the control what they can have on the data or some kind of protocols, or there are certain I would say industry guidelines at certain times they need to follow in order to be able to cater to the demands of the project that they are working on. Suppose if you are working for the healthcare industry, there is something called as HIPAA compliance. These are the compliances based on which the organization has to operate in order to be aligned with the statutory governance bodies. Similarly, we have the Sarbanes-Oxley compliance, right? So Sarbanes-Oxley compliance is also very important when you're dealing with finance-related data. Okay, so
I have a doubt. Can I ask?
please go ahead. Yeah.
Sir, which is best we should study? DevOps, Azure, or AWS? Which is the most which has more opportunities, or which is the cloud most of the companies use? Can you tell, please?
See, when we look at, DevOps is something which is common across all clouds. So when you talk about DevOps, you're talking more about managing the platform in terms of managing the different services, so users and so on and so forth, right? So, but in this here right now we are discussing about data engineering as such. So when we talk about data engineering, we're talking about how we can bring in the data from different sources and pull it into a data warehouse for eventual consumption for decision making. Now, again, when we talk about data engineering, cloud computing, under which we have data engineering in the Azure context, Azure is something, that's what I was telling, right? Azure is something which is very promising considering the way it is growing, okay? And the kind of modules or services that they have come up with to help the data analytics, data engineering, or data science, or Internet of Things, big data, any of these subjects, it is something which is growing very rapidly, right? And the future is going to be completely data driven, right? So people are not going to do anything without knowing what to do with the data. So it's very, very important. So as such, we are actually promoting Microsoft Azure because we have a very, very strong feeling, and also based on the statistics, there is a very good job opportunity or job market for people who will know how to work on different data engineering services and modules in Azure platform. Okay, so at the same time, AWS is also an established platform. But looking at the way things are happening and the way Microsoft Azure is growing, it is something which can help you have a very bright future if you work on the different modules. See, once you understand one cloud platform, it's not difficult to understand the other platforms. So now, to summarize what I said, one is data engineering, and within that, when you're looking at data engineering, which cloud are you focusing on? Our suggestion is to focus on Azure. Yeah. Okay, we have Mahanta, who's our senior faculty who has joined in. So, so we'll leave it to Mahanta for 10 minutes to introduce and talk about data engineering on cloud platforms.
So, sure. Is it our responsibility to provide security for cloud, or is the?
See, there are a lot of security related protocols that can be applied, or security related or security and data governance related applications that can be used on the cloud platforms, right? There are many services that are already available using which you can make your applications or your data by itself very secure. Okay, so Yeah, again, so when we talk about things from a data engineering context, there are data security rules that you can impose on the data. For example, if you want the data, if you have built a data warehouse, you can impose the row level or column level or table level security on the data, right? At the same time, you can do data auditing on who saw what kind of data, right? So all these are there. That this is what it's all about, right? When you look at data engineering, this is all is what it is, right? So understanding the nitty-gritties of how to work with the data, what data to make available to the users, what data not to make available to the users, so on and so forth. Yeah.
Is coding important for learning cloud computing? Coding knowledge.
See, we don't have too much of coding here except for writing queries, SQL queries. SQL queries is very important, right? So if you don't know how to write the queries, you will not know how to retrieve the data, or you will not know how the data is going into the database or how it is coming out of the database, right? So writing queries is the only thing that we are focused on. Rest of it all has graphical user interface, right? It should be easy for you to understand and learn it. So you don't need heavy coding at all. Yeah, so I would like to introduce our senior faculty, Mahanta. Mahanta comes from extensive industry background, more than 20 years of industry experience. He is highly proficient in big data and related technologies. I'm happy that he has joined our webinar today. Mahanta, if you can go ahead and give some insights to the participants today, that will be very helpful.
Okay, wonderful. Hey, good morning. I could see Akash is there, Elbin is there, Jeffin is there, Jitendra, Manju, and somebody is there with Redmi. Who is with Redmi? What is the name of the Redmi person? Rishabh is there, Srivastav is there. Redmi person, you don't want to say your name to us? What's your name? Redmi? You can unmute.
Sufyan, I think.
Okay, wonderful. I hope all of you guys are doing great. Thank you, Punesh, introducing me. So, like basically, if you really, there is a reason for all of you guys to be there here as a part of this discussion. Okay, so we are like, this is a more of a cloud data engineering course. And if you really see, I mean, in a recent, from last around 10 years or so, right? I mean, the data has become a new oil. Okay, and that too, one more aspect which has emerged in last 4 to 5 years is the data on the cloud. Okay, so that is the reason we are really focusing on this particular course. Whenever we go to any of the implementations in the recent past, okay, all of them are more or less like they are implementations on the cloud. Okay, the data implementations in the cloud. Okay, so there are two aspects here. The first aspect is the data. Okay. So if I ask you a question to Rishabh, so Rishabh, do you know Chitragupta? Rishabh Mishra?
Yes, sir. Yes, sir. Yes.
Who is Chitragupta?
Sir, he who writes everything. I mean,
right? Chitragupta is the assistant of Yama, right? The data is there from those days. Okay. And data is never ever going to be out of fashion. It's always hot, it is always sexy. Okay, so that is the first aspect. The second aspect is, if you really look at the now the whole infrastructure. Okay, when we say cloud, other day I heard about there was one leaked video from the white hat junior teacher explaining that cloud is in the air, Okay, I hope I don't know whether any of you seen that video or not. Okay, so the cloud, when we say talk about the cloud, we are talking about the infrastructure on the cloud. I mean, in the data centers, which will be accessed to the network. Okay, so now with the advent, thanks to our Jeff Bezos and all the people who really contributed to the the cloud becoming famous. So the cloud has become a part and parcel of any of the companies. Okay, especially with the startups, the cloud is very important. Any company for that matter. Okay, so now we are talking about the two things here. One is the data, the second thing is the cloud. Okay, so as and when we progress, most of the companies need to be there in the cloud. When I say cloud, I'm talking in terms of infrastructure. Like anyway, we'll talk about all those things in detail. Okay, so these are the two aspects. Okay, these two aspects are going to rule the world in a decade to come. In another decade, the data and the cloud is it's going to be very, very important. And any organization, do you think any, just let us say, let me ask a question to Jitendra. Do you think any organization can escape from storing the data and processing the data, Jitendra? Jitendra? Okay, seems to be Jitendra. How about Manju? Do you think any company can escape storing the data and processing the data, Manju? Manju Hegde?
No, sir.
No, right? So every company has to store the data and process the data. Okay. Now, when we talk about, see, that is the first point. Data and cloud are going to be the important. They are one of the, I'm not saying the important, they are one of the important as compared to the data science, blockchain, as compared to the artificial intelligence and all those. At the end of the day, data is feeding every technology. If you look at the AI, data is feeding that. If you look at the ML, data is feeding that. Okay. So that is the one first important point I want to make. The second important point is, if you really see the let's say any idea, Srivatsa, any idea who is the person who kind of came out with the white paper for the RDBMS? Srivatsa? Or anybody in the group who can tell me who is the person responsible for the RDBMS? Okay, it's Edgar F. Codd. Around 1970s, this Edgar F. Codd came out with the white paper on relational database management. Since then, the relational database management become the part and parcel of any of the IT infrastructure, right? So now, in the, especially if you really look at in couple of 6 to 7 years back, the big data became really, really famous, right? So then if I ask you, like basically what happened is the people thought SQL is going to go away. Big data is going to be really, really prominent and all those things. No, SQL is not going away anywhere. SQL has become much more stronger. So as a part of this course, what we'll do is we'll just start from the very, very basic of SQL databases, and then we'll migrate to another way of processing the storing and processing the data, that is data warehouse. Then we'll introduce you to the big data aspect, because if you really look at any of the data ecosystems, right, it will have SQL, I mean RDBMS systems, it will have data warehouse, it will have big data. So what we are planning to do as a part of this course is cover all these important aspects of the data storage and processing on the cloud. Okay, that's it from my side. Any questions for me? I need to log off in another 5 minutes. Any questions for me before I log off? Akash, Jeffin, Jitendra, I hope you guys are doing. Any questions for me? Rishabh? Yeah, Jitendra, you are supposed to ask something. Go ahead. Fire, don't worry. It's okay. No, Jitendra wouldn't want to talk. Ilbin, you are asking so many questions. Any questions for me, Ilbin? Ilbin Raja.
Data is part of data engineering.
You are a bit low. Can you be a bit louder, please?
No, I'm asking whether big data is part of data engineering.
Yes, of course. Big data is part of the data engineering. Yes.
But not part of this course, though.
Okay. Okay. Yeah.
Yeah.
So this course is, we are just introducing you to the, it's kind of a precursor course. Okay, Jitendra doesn't have any questions from his side. How about you, Manju? Manju or Jeffin or Rishabh?
No, sir.
Okay, looks like you guys don't have any questions for me. All right, you guys have a wonderful day. See you somewhere when we start the course. Thank you. Thanks,
So
Punesh.
Azure Data Engineering. Okay, what is covered? So basically we covered the database concepts, which include SQL and NoSQL databases. So we may go ahead and work on writing SQL queries on Oracle database, At the same time, we may take another database like Amazon Redshift, which is a columnar database, and work on that. So that way you will get an idea on why to go with Amazon Redshift, when to go with Oracle. So that's the basic thing what we start with. So second is we'll deliver lectures on data warehousing, ETL, and data visualization concepts. So again, which is very essential for data engineering. With this, you will understand how to take the data from multiple sources, how to create a data warehouse, how to load it. Again, a lot of graphical user interfaces through which you can work. No need for you to do any intense coding here. So then we'll look at Azure Data Engineering services or modules within the Azure cloud, which will facilitate the ETL processes or OLAP process. For example, Microsoft owns Power BI, right? We'll look into Power BI. We'll also look into data pipelines in Azure. And also we'll look at how to handle large volumes of data using Synapse Analytics, right? So on and so forth. So good amount of topics that are covered, and the biggest advantage here is the cost effectiveness. So you can see the program. So you can also go to our online landing page for this particular training program and get yourself enrolled. Okay, so Azure Data Engineering, you will learn what is Azure Storage, Data Factory, Synapse Analytics, Power BI, and to a good extent, what is Azure Databricks, right? So at the end of the training program, you will also have a small project wherein you will be given a business case to work on, so which will be on par with the industry standards. If you're really serious about your career, if you do this training program, definitely you will be able to add in good amount of value to your resume and apply for a better job. Okay. So because most of the candidates whom we see when we interview candidates to take them to our company, biggest problem is they don't know how to write basic queries. They don't know what are these components, right? So the very basic things they don't know. So if see, all we need, if we are hiring a fresher who is new in the industry, all we need them to know is the basic stuff. But still they falter on the basic stuff and they don't really understand that, right? So the basics are very, very important. Okay. So what I would say is it's important for you all to understand how to write the queries first, right? So recently we had one of our clients who wanted us to deploy some candidates to them, and their primary requirement was, okay, even if they don't know what is a BI tool, they should know how to write queries, right? Writing queries was very important, and they wanted the candidates to know what is data warehousing, what do you mean by star schema, how do you organize the data into dimensions and facts. These things people don't know, right? So this is where the biggest problem is in the market, because they go to some end of the training program, will also give you a certificate. Okay, certificate will also be a good advantage for you to apply for jobs. So as and when we are delivering the training, we'll also keep telling you about how to face the interviews, what are the interview questions that will be generally asked, how to clear the interviews, what are the soft skills you need to have, right? So how do you work on a software development lifecycle methodology, so on and so forth, right? Apart from these training programs, we do have training programs on big data or cyber security, purely data programs purely focused on Python, right? So, and data warehousing, ETL and OLAP concepts, right? So if you are interested in doing anything further on that, okay. So I'll just share the link where you can go ahead and register yourself. So this is the link where you can go ahead and register yourself, learninghelp.com/enroll now. See, I would say it is not just the basics. It also has some good advanced concepts. So if you're really keen in learning this, once you learn this, you can build on it all by yourself. You don't need any additional course beyond this. And you will also be able to clear the certification if you work hard on same curriculum.
Because you said big data is part of data engineering. For this course, big data is not doing.
Yeah, so big data comes under the data engineering. See, data engineering is a very wide subject altogether, right? So there are a lot of concepts. As I said, we are focused on cloud data engineering right now. So when we are focused only on Azure, within Azure, we have one big data component we're using Synapse Analytics, right? So previously it was called as SQL DW, and within Azure, wherein we would do more of ELT. So that actually takes care of the big data scenario. So there's one element of big data in this training program as well.
Sir, I want to ask, I am from civil engineering background.
Mm-hmm.
Can I do this course?
Yeah, definitely you can do. So as I said, see, this is not see data. When you talk about data engineering, you're not just talking about writing a set of code, right? So you're talking about writing. You're talking about building the required infrastructure for analyzing the data. So that being said, regardless of what discipline you come from, as long as you have the right mindset to learn and get into this field, you can get into this field. But you need to just focus on things and understand things in a better way. Okay. So regardless of whether you're from civil engineering background or computer science, I've seen people who came from BSc, what is it? CBZ, right? Botany, zoology, that background who became data architects. It's all about your interest. As long as you have the technical bent of mind to understand things, that should be good enough. As I said, we have simplified it to a very good level. At the same time, we have included advanced concepts as well. So as I said, if you go through this course, if you are serious in your career, this should be good enough for you to secure a good job, right?
Okay, sir. Thank you.
Yeah, yeah. Any other questions? Okay, so if we don't have any further questions, let's conclude it. So I really appreciate all of you for taking this initiative to come and attend this webinar. Hopefully we'll see most of you in the training batches, which will be starting on 7th and eventually on 10th. So if you have any further questions, regardless of whether you're joining for the training or not, you can definitely write to us, and we'll surely make sure that we'll respond to you. Otherwise, we wish you the very best of luck in your future, in all your endeavors. All the best to you, and thank you for joining me today. Take care, all of you.